Humanoid robots, my friends, the ChatGPT moment for general robotics is just around the corner. And in fact, all of the enabling technologies that I've been talking about is going to make it possible for us in the next several years to see very rapid breakthroughs, surprising breakthroughs in general robotics. Now, the reason why general robotics is so important is whereas robots with tracks and wheels require special environments to accommodate them, there are three robots in the world that we can make that require no green fields. Brownfield adaptation is perfect. If we could possibly build these amazing robots, we could deploy them in exactly the world that we've built for ourselves. These three robots are, one, agentic robots and agentic AI, because they're information workers. So long as they could accommodate the computers that we have in our offices, it's going to be great. Number two, self-driving cars. And the reason for that is we spent 100+ years building roads and cities. And then number three, humanoid robots. If we have the technology to solve these three, this will be the largest technology industry the world's ever seen. And so we think that the robotics era is just around the corner. The critical capability is how to train these robots. In the case of humanoid robots, the imitation information is rather hard to collect. And the reason for that is, in the case of car, you just drive it. We're driving cars all the time. In the case of these humanoid robots, the imitation information, the human demonstration is rather laborious to do. And so we need to come up with a clever way to take hundreds of demonstrations, thousands of human demonstrations, and somehow use artificial intelligence and omniverse to synthetically generate millions of synthetically generated motions. And from those motions, the AI can learn how to perform a task. Let me show you how that's done. Ladies and gentlemen, this is Nvidia's latest AI supercomputer. And it's finally called Project Digits right now. And if you have a good name for it, reach out to us. Here's the amazing thing. This is an AI supercomputer. It runs the entire NVIDIA AI stack. All of NVIDIA software runs on this. DGX Cloud runs on this. This sits, well, somewhere, and it's wireless or connected to your computer. It's even a workstation if you like it to be. And you could access it, you could reach it like a cloud supercomputer, and NVIDIA's AI works on it. And it's based on a super secret chip that we've been working on called GB110, the smallest Grace Blackwell that we make. And I have, well, you know what? Let's show everybody inside.
Because the CES, I didn't see something interesting in CES. I just saw some videos from the CES that it was mainly Nvidia and just some humanoid robot. It just sounded to me not interesting at all. But I didn't find something interesting.
I mean, unfortunately, there was like a lot of humanoid bots that were, the seedy side of humanoid bots that were on display. It seemed to be getting also news, and it's like that's unfortunate because it's almost like if you want to push against the whole thing, push on that side of it, and then people will have a distaste, and then there'll be this uproar about, oh, we can't build humanoid bots. It's like it's not about that; it's about something else. I think the interesting thing was probably, the keynote address from Jensen, of course, is very, very important. And his focus was on the robotic space. Again, he had the stage filled with humanoid bots, emphasizing that what he's been talking about hasn't changed. That's still a very, very key thing. And I believe there was some questions there about how, um, basically how AI is going to solve the motion problem, and this idea of tokenizing motion that he brought up again and again, which is something I've been trying to think about as well, as how it relates to the way you train an LLM versus how you start training with the motion. And I think it's rather
I think
interesting insight.
someone asked this question for you actually in the podcast chat.
Yeah, I think that was in there. Right, right, and I think part of it was prompted from the fact that, he's showing that whole pipeline, which means it's not something he's not shooting from the hip. This is something that is they've really been thinking through what needs to be done in the architecture and how it's going to work. And, some of it may go back to the way training on LLMs work and what a token means, okay? So, in some ways, you could think of a token as like a letter or word or syllable or, a proper root of a word or something like that. But for the most part, it's like a word, and you're trying to string these tokens together to create a sentence. So words put together create sentences. And of course, we know within our grammar, we have different roots of words with different endings on them, which tends to be why these tokenizers will get the idea of the root of the verb and then have to figure out what's the ending going to be to make sure that that's all correct. And they break it down. And then, of course, to properly spell out a word, you have to understand a little bit about how the alphabet and all those things work. And you can think of these always as tokens that get consumed, and then there's some sort of rule in how they all get applied. And the early LLMs, the way they work is that basically, grammar is kind of a human construct in that we've tried to figure out how our language works, and we've broken it down certain ways that seem to make sense on certain ways. But at the same time, the whole idea of grammar is to show what the rules of a language are. And depending what the language is, it turns out like the irregular verb or the exception to the rule is the rule in some cases, as opposed to initially, following something. And so it can be very hard to tease out, what actually are the rules of a particular language or anything, because there can be a lot of exceptions. But we know LLMs are pretty good at figuring it out if you give enough. So that the head start was like, well, we're going to let you know that there's this thing called an alphabet, and in that you string these letters together to create words and stuff like that. That's the stuff you should be looking out for. And so you give them a little bit of rules. And the same thing was kind of done with chess playing bots. It's like, they were kind of shown what the rules of the game are. Then they start to play to learn what the strategies are. But then eventually they realize that, we don't even have to teach them the rules of the game. We'll just keep on showing them examples, and they'll figure it out. And that shouldn't be a surprise, because you've known there's like a lot of these chess prodigies that they'll sit there and watch like their parents play chess, and they'll figure out the rules. They won't be told what the rules are. They understand what the rules are, and then they figure out how to play from there. So it shouldn't be a big surprise you could do that. So a lot of the LLMs right now, they don't even teach them the concept of letters and words. They just feed it so much, and it just figures it out. It's like, oh, this is how you tokenize everything. These are the proper things. And who knows, they may be coming up with slightly different grammatical rules that make more sense than what people have been able to figure out, because we know AIs a lot of times are finding solutions to problems that no one ever would considered could be a possible solution. They're optimizing things a little bit differently. So I wouldn't be surprised if they have their own way of thinking about language. And that makes sense, because you think about it, we could all speak our language before we had to go to grade school and they started teaching us the concept of grammar and what was the proper way. And sometimes it may not have quite fit into like our worldview of how the language worked, because we have like this intuitive sense. They keep an eye about it's about the ear. It's like it sounds either right or wrong to your ear. That's why you know how to do it. It's not because you're going through some grammatical table that's how am I supposed to decline this verb now or something like that. So it's sort of the same thing that's going on. So how does that apply to motion? Well, um, do you start telling it how to break different movements down, which may be one way, or to figure it out. So if you go to the old school way of looking at kinematic motion, if we look at my hand and how it moves, the thing is my fingers can take an infinite number of positions. Any one finger could take some value between 0 and I don't know, 90, 100, 120, whatever that angle is. There's an infinite number of combinations that are kind of in there. And we just apply it with different angles. But the reality is, our for most gestures we do, there's like a discrete set of positions that we would commonly kind of go into. And so, yes, I can take my fingers and they can go through a particular set of movements. And sometimes I can go down like this, sometimes kind of like. But if you were to look at everything I did, you would begin to find there's more common positions that I have with my fingers than the ones in between. The ones in between are just how you get from A to B. But a lot of times there's a place that you like to rest in there. And you can start to think of those maybe as almost as like letters that make up maybe a particular word, or so a token that could make up something that's a position of my index finger. And then you do it with all the other fingers, and then you start looking, so from those you can start to make the concept of maybe a sentence or this or paragraph or something of where your hand needs to be to do something. And so that's one way of kind of tokenizing. And then there's this other thing that you may have heard of. There's something called Benford's rule, and that is kind of showing um, the the frequency that certain things appear. And you would think that with the 26 letters that we have in our alphabet, they all make the same appearance in text, and they don't. There are some letters that appear way more frequently in words than others. And, famously, like, X, Y, and Z are almost at the end of the alphabet because they're very rare. Q doesn't show up. And the reason why in Scrabble, the letters have different values because of the commonness and stuff like that. And that's been well shown, and you can put it in a plot, and it just goes zip down like that. And and it applies to a lot of things. Like everyone's always wondering, like, if you look at, like, a lot of units that are out there, when we do measure stuff, they always tend to be in the order of like one or something, have like a one in it, 10 or 100. Why is that? And it's like, it turns out to be like this Benford's rule is going in there. And even accountants use it because people are really bad at knowing what like random numbers are. And if you got some guy that's like cheating on his taxes or his expense reports or something like that, the numbers they put in tend to not obey Benford's rule the way it should. And so auditors will run that through and they'll start looking at it and go, this isn't really, and that's when they know to dig in a little bit deeper. So there are these ways you can kind of look at. And so the same thing is going to happen with the frequency that's going on with the movement that you have, is that you'll have like this infinite possible combinations of my hand. But then as you start studying the motion, you begin to realize there are more common ones and less common ones that, right down to kind of the fingers. And then a lot of times the movement of one finger almost dictates what the others can do. You can get into some positions, but they begin to feel kind of awkward and hard. So it's the same thing that, putting certain letter combinations together just don't go well in certain languages. And so you kind of like, well, we're not going to do that because it's really contorting everything that's going on. Let's go to the things that are more, and so that will get teased out. So you show enough examples of that, and then you begin to get those tokens. Now, internally, LLMs they've tokenized their concept of what's going on, and then you can ask it to output that in any other language. So it basically has its own internal um, dialogue, which is probably not in English or French or German or any other language. And then it can kind of spit it out in what you want. And so what's happening is that you've got, it's got this internal concept of what it calls these things, which we would not understand at all. But you can then start asking it, or you can then start labeling what those things are. So it could be that, this finger combination is like, the G chord or something like that on a guitar. So it's like, show me a G chord. Whoop, that's what it is. Show me grasping an egg. Oh, it's gonna be like that. Show me grasping a pipe. Oh, it's gonna be this. So eventually, you would be able to then sort of say that, how do we make the combination between what I want you to do and that? So, just like they say, Eskimos have over 300 words for snow. Uh, it's sort of the same thing that, there'll be 300 words for grasp. There's not just one way to grab something. There are like multiple ways of being able to grab something depending upon what that object is. And so you're going to start building up this extensive vocabulary that'll go between them. And that means once it's seen enough of those examples, there may be two ways that you then start to train the bots. And that is either you just tell it to go grab that tennis ball on the corner there and it'll just go over and it knows exactly what to do. The other is that you show it grabbing a tennis ball and then it goes and does the same thing. And of course, the last episode, we went a lot through this whole idea of, having the telerobotic outfit and stuff like that to be able to show all these examples because it needs to have the clips. Eventually that goes away. And it just like, teaching the AI the rules of the game. It's like, we don't need to do that anymore. Just show it the game and it figures it out because it has enough of a concept of how everything works. So at some point, the training the bot is just going to be the monkey see, monkey do. Just look at me and just do the same thing, or in some cases, describe it. So we know when you have an apprentice and you're showing them how to do a particular thing, a lot of times you're showing by example. You're going through showing all those things, and maybe every now and then, correcting them when they do it, and that might be showing them or physically explaining it. Then there are other times where you have, you know, a relative or someone call that says they need help fixing something and they're not on video or anything like that. And you're going to talk them through what to do to, to get something going that's kind of broken that you're familiar with. And at that point, it can be sort of a language-based description that they would then be able to figure out. But of course, the easiest thing is to be locally there. So yeah, there's going to be a lot of effort and these telerobotic stuff, which is going to be needed to kind of get the system up, to bootstrap the system a little bit. And then at some point, they ought to be able to figure it out. And it's interesting how intelligence works. That um, in many cases, we think there has to be kind of this one-to-one relationship. If you show someone how to do something, it's like, you're showing them doing it with the right hand, you expect them to do it with the right hand. But if someone's left-handed, they can figure out, it's like, well, I'm going to use my dominant hand instead of what you're showing, and I can kind of figure it out. But still, it's the idea of using your hand for this or that. But every now and then you'll have these animals, and you constantly see these videos on social media of like cats and dogs imitating what their owners are doing, yet they don't have the same appendages. So a lot of times it's like they can't do it with a hand, so they do it with their mouth. It's like, well, wait a minute. It's like, don't you understand that you have a paw here? But they know they can't grab with their paw, but they can grab with a hand, and they can understand that same thing. So you will see eventually that these systems that may not be similar to us will be able to understand the idea and say, oh, well, I don't have a right arm or a right hand. I got something else that can do the same thing. And eventually it comes. So that's kind of this translation. And I mean, that's the way language works. There's a concept of an idea, and then we figure out how to translate it from one language to another so that the people on either side can understand or grasp the idea. But ideas um, don't depend on a language. They're independent of them. They're just expressed through language. And yeah, every now and then we do some cute things with our languages that are difficult to translate from another, where we get into poetry and stuff like that. It's, kind of hard, and jokes don't translate that well from one language to another, that are really based on, like dad jokes are probably pretty hard to translate, since, they really depend on it, but they get kind of the idea.
And I think what was interesting about the new GPUs by Nvidia, I don't know what your take about it as well. The GPU.
Uh, yeah, I mean, it's just gonna get crazier and crazier. So the 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 better you can do, um, the visualization to look realistic, the easier it is going to be training a lot of these systems for different conditions that they're going to come into. Because this has always been a problem with vision systems, way before AI, is that you would have these lab-based camera systems that would go through to try to identify parts and everything and work great in the lab, and then bring it down to the factory floor, and it wasn't working, and they were trying to figure out why. It's because the lighting conditions are different. For one thing, the shadows are being casted are different. The parts that are coming in have a sheen on them that, the sample parts you have in there, because, they just came out of a press or something. So they have a little bit of, and so then they realize, man, we have to account for this, that, and everything else. And so a lot of times, if you're trying to train these not in situ, but somewhere else, you need to emulate that. And this is like a lot of early driving systems, a lot of the early driving simulators are trying to do this, to say, well, we need to learn to drive this one particular set of roads. But the thing is, we want to do it rapidly. We don't have to wait 1 or 2 years, because there's so many conditions on that road, day, night, winter, summer, raining, not raining, fog. It's like you want to train it with all those conditions. And so if you can just like snap your fingers and magically take a situation and change it to all these different things to make sure it sort of understands how to behave under different conditions, that's very good. And to bring more realism. Now, there's one thing to get the appearance to look right. There's the other is to get the behavior to look right. And that is mastering physics. And physics is really, really hard to get right. And the thing is that sometimes they can trick us. I've seen a lot of these videos that are like really impressive. There's some slew of videos where they're always showing like these different car bodies and what would happen if like crashed into this wall, or a 10-ton steel rolled onto those things. And you look at them and they're like really darn convincing, and they may have been done pretty well, but I have the reality, if they actually were putting the real ones out there, it would not behave at all like that. So, your gut is telling you kind of looks right. And there may be a certain amount of physics behind it, but the real world is way more messier. And to get it down right could be something else. So we'll get that first guess on how you need to behave in certain situations. But then the robot will go out there and it might be say, well, wait a minute, this is very different. And of course, if you ask any athlete, it's like, yeah, you practice for the game and stuff like that, and you've never, played. It's like when you get out there, it was completely different. It's like, yeah, I was not prepared for it. Like, the big crowd, the shouting crowd, and the grass was different and everything else. And all those, and, the other team looked like a lot more intimidating. And I was, like all these little things that will kind of come in. that even though you've kind of practiced and think you're ready, when you actually have to go out there and perform, you're going to find that it might be tricky to adapt to the conditions until you start doing that again and again. So that's the difference between sim to real. It's the same thing. It's like, practicing for a sporting match and then actually going to the sporting match. You'll say, well, the practice helped, but boy, there's nothing like the real world experience, the game time experience. And this is what you have to try to figure out, how much of these GPUs you're going to need in others to help you in Isaac Sim, which helped out a lot. But in the end of the day, you got to get out into the real world and get a lot of it, which means you need to scale up your bots. And the question is, what's that number of bots you need to actually start collecting enough reasonable data? Is it tens of millions, which would be like, a ridiculous amount, or is it just in the order of hundreds or maybe a couple of thousand to that? And then kind of speaking of real world and doing that, CES, you had the announcement from Jensen, about all these things and the importance of it. And everyone was going on about all those things. And then like half a world away, I think it was like in Shenzhen, suddenly like this video pops up of a
Yeah.
humanoid bot walking in the wild amongst
You mean
a crowd that
the startup company, the startup name? Sorry, what was the name? You
the
said
engine, I think it's Engine AI, Engine AI, and they released a couple of videos like a month or two ago. And I think they actually had something at CES, but they had a much smaller bot that was there. And surprisingly, they didn't get a whole lot of attention there, but they created kind of a stir and a buzz outside of CES on this because it was kind of shocking. And for some, it wasn't that shocking because we had seen a preview of this bot like walking in their lab, I think back in the fall. And um, for everyone was really trying to understand what was going on because it was like walking too good. And it was like,
to be
but it
honest,
was like a green, yeah.
the boss you sent it to me. It seems
Ye-
to me CGI, but I read your analysis. It's not CGI, but the way it
It's
walks,
not.
it feels.
It,
It's
it
not.
yes, yeah. Yes, yes. So what we saw is like a couple of months ago, there was something in the lab and you were kind of looking at it and it looked pretty good, but at the same time, there you couldn't 100% rule out CGI because the quality of the video, the lighting that was in there, and it wasn't there. And the main reason why people were suspicious is that it was just too darn good. It's like how could we got all these other people doing it, how come they're solving a bunch of these problems you doesn't have it? And then this suddenly shows up out in the public square, and there's lots of cameras around there, and suddenly one grainy video kind of shows up, and my feelings like, okay, we've got it from one perspective, but there are a lot of cameras there, and if we don't start seeing it from a bunch of perspectives, I'm going to be, to me, there's something going on here because I would think everyone would be posting, and sure enough, probably within hours of my posting that, it's like a bunch of them start showing up, and we start seeing the failures of it. I think being put off there, a lot of other things, and it was consistent. And the main thing is certain lighting conditions make it a lot easier to tell whether it's CGI or not. And they did it on kind of a cloudy day where the ambient lighting conditions are such that it's like a lot easier to trick the eye because there's not like these distinct shadows that are being cast with these faint ones. And it's like I was going to just keep on giving the benefit of the doubt, but I couldn't say that 100% sure that it's right because this walking is doing almost everything too right and to make everyone suspicious. And that is two things. One is leg was straight. It's like everyone's talking about like their knees are always bent. So when it was coming down, it was having like a nice straight leg, good heel toe coming off there, and its stride length was like really long. Um, and that made a bit, and somewhere in here, so I actually have it up here, and I can probably share it, and then we can go ahead and take a look. And you can see why it's like it's AGI, or let's say AI is so good nowadays and all these other things. I mean, think about it. Think about a year ago, you saw a table tennis playing robot that was like just amazing. That was, a bot that was going around and like, just was playing cat and mouse with the human player and kind of walked away in a, triumphant way of like just finding a little thing. And everyone recognized it. Says, yeah, we saw that, like, that was like a very famous kind of volley going back like 5 or 10 years ago. And someone just took the human and was able to replace them with that with the animation. And it looked, almost pretty convincing. And that's why when you see these things, you just don't know, especially I've never heard of the company, all this other stuff's going on. So, and even Jim Fan, he was like, does anyone know? John Gibbs looked at it, who works in the field of CGI, and he couldn't find any telltale signs, but at the same time, he said that the level of detail on it was such that you couldn't go the other way either. And I was more or less like, I can't rule it out one way. And what I was thinking, the only way I could look at it is the walking motion. And again, rather than my just chatterboxing along here, let me go ahead and bring this up. If I can get this back on up here. And I think what I need to do here for a second is go ahead and share. Let's go ahead and get that, see if I can share my screen right now. And I'm going to share the entire screen here. And that should be this one here. Share. And now I need to pop up the actual video. Oop, and and the video should be, there we go. We should kitty, the video should be coming up right now. Okay, so let me get this right back to the beginning. So again, this is quite out in public. There are a lot of cameras there showing this. Very confident stride. You know, you see how the knee is like very straight when it comes down. And look at the length of that stride. I mean, that's a beautiful length stride. All the other bots we're seeing is like 1 foot literally in front of the other. And this one is meandering around, just kind of going on down there. Um, but the thing that's hard to tell is because this is a mechanical walking, there's a certain stiltedness to the walking that doesn't quite look right as a human because, you know, the vibrations are going through the system and everything else. And I'm used to when I do a lot of simulations of bots, if someone puts in like a really funny acceleration value or something like that, you can almost see it. You know, it's like, wait a minute, the thing doesn't seem to be accelerating. There's this instantaneous movement. There's something else, as opposed to when it's in there, you can see it. So a lot of times your eye is trained to that. Now, we don't quite have enough frames in here to be able to tell, but you know, to me, there was just something that just didn't feel quite right. That I would have to do a full blown analysis to really know for sure. Is it like this instantaneous velocity? What's going on there? But that's like, let's say, more of a feeling that we're getting because we're used to the natural motion of a human. We're not used to what a mechanical being should look like. And it looks pretty darn good. But then again, I've seen so many Marvel movies that, you know, really convince you that that's Iron Man there when you know it's all done in CGI. So it's, you know, we've been able, I think, confirm that they really have done it. In which case, they, you know, props to them for being able to do that because
So what they did differently? Like my question here, what they done differently from like figure, for example, your position dynamics, like its competitors already.
this is all using reinforcement learning out of Isaac
Mm.
Sim. So somewhat was confirmed. I think Jim Fan was able to go. It's like, yep, they trained it in Isaac Sim through reinforcement learning. So rather than using a traditional control system and just it basically learned to walk to figure it out, and that could be the
Mm.
big difference. Now, you know, why do we have, you know, all the other bots? Their knees tend to be bent a lot more when they, you know, everyone keeps on talking about. It looks like they're wearing a diaper or something like that. They're squatting down. They're walking like a toddler. What's that about? And a lot of it is just kind of the need to make sure that you have um, enough possibilities to control your fall one way or the other. So as soon as your knee is locked out, there's only one way the knee can move. And if you start to move your balance, then suddenly that means there's only one thing you can do with your knee. You don't have the choice to go one way or the other. So that limits your options. And you would and the reason why when we're in an unfamiliar territory or we're carrying something kind of heavy, we will also squat down and bend our knees a little bit because we just kind of know having the ability to, you know, sometimes maybe we need to make our leg a little bit straighter to prevent the fall. But if our leg is already full straight, I can't make it any straighter. There's only one thing I can do. I'd probably fall backwards now at that point. So um, so you have to have a certain degree of confidence in your balance and control to be able to do it. The other thing is that maybe they're doing something down in the foot because our feet
Mm.
are very, very important to balance. And so long as you kind of keep your center of gravity over, you know, within the static margin of your foot, just flexing your toe and doing a few things like that can go a long ways to you keeping your balance. So you could stand yourself straight up and you can feel that you can adjust your body forward and backwards sometimes just by flexing your toes using a little bit there. And so those are like the subtle fine tune controls that you can have. They may have done a little bit there because they do have some pretty good heel toe movement going on in here. And you know, overall it's a very good stride. The other thing that I think they've done that's helped a bit, because we'll see there's some points here where the stride is just like really quite long. Um, and and that's part of the reason why its walking speed is so good. You know, if you're taking short strides, it takes a lot longer to, you know, it's a lot harder to go faster because the swinging of a pendulum, if you think about it, the frequency of the spinning of the pendulum is the same depending up it's independent of amplitude, right? It's so if I'm swinging a short amount, the amount of time it takes me to swing that short amount, and let me like unshare for a second here, so see what I'm talking about. Yep, and I think we're up again. Is that if we take something that's a pendulum, like this, and the frequency of it going back and forth this way is basically the same whether it's big. So, if my stride is kind of limited by how many frequencies, steps per minute or steps per second that I can take, if I can take a bigger stride, I'm going to get more velocity out of it. And it seems like all the others are just being very timid and going for the very small frequency where they're getting the much bigger frequency. That just helps them right there. The other thing is that your stride length is also dependent upon how long your arm is here. And so if I make this shorter, for 30 degrees back and forth, I get a lot shorter stride than I do here and there. And if we look at their bot for a second, the couple things they've had to do, and this is that we need to kind of look at what's going on, and I'm getting it to refresh here. Okay. Um, in the hip. Now, if we take a quick peek at their shoulder, we'll see their shoulder is the same as everyone else's shoulder. What's interesting is all of the bots that are out there, everyone's shoulder is the same, with probably the exception of clone. Okay, but
Yeah, did you show,
everything
by the
about
way,
them
the
is
clone
different.
video? It was in the end of the year.
Oh yeah,
It
oh
was
yeah.
impressive.
It's absolutely impressive. Okay, so the human shoulder and the human hip is a ball and socket joint, but none of them are using a ball and socket joint, with probably the exception of clone, just because of what you have to do to actuate it. So they haven't done anything novel on the shoulder. Um, however, everyone is experimenting with the hip. No one has figured out what they want to do to the hip, and everyone's is different. Um, and we've talked about this before, is that one of the problems that I see in Optimus is that, your most important motion is that swinging motion of the leg. And you have this kinematic chain of actuators that has to build the rotation that's in on your hip. And that swinging, or what they would call flexion, is being done here down on the third motor of this kinematic chain, the same as Optimus is. Um, Figure one did that as well. It had it down there. The problem is that, like, your hip is kind of up here, yet the swinging motion is down there. It's kind of out of sync of where it wants to be. So, Figure switched it around and they made like their joint one, the flexion joint, and everything else. They've decided that no, they're actually going to make it the third joint down here, but they probably got away with it because they're lifting, in a sense, those actuators up much higher than they would normally be. They're more in your belly area as opposed to where your pelvis would be. So it's much higher up. So they make sure that their legs are like the same length as a human. Whereas if you try to put this at the same level down here, you're just going to shorten the legs. It's not going to work out right. And that's kind of what's happened with Optimus, is that Optimus's leg length and therefore its stride length is kind of compromised a little bit because of that. And now there's a disadvantage to bringing this up. And what is that? The rest of your torso gets smaller. It's space claims. So that means you have less room for your battery pack. So the decision to what you're making down in the pelvic area in the torso is going to eat into what you might want to have up there. So that means that's probably, they're sacrificing
There's
a
all
little bit of
so
battery life and the position the battery is going to be there by
so
having so much of that kind of consume the lower part of the torso. In order for your stride length to be long, you want to have longer legs. And the length of your legs really comes down to where that point of rotation is for the flexion, which is the stride going forward and backwards, a swinging motion back and forth and back and forth. And if you look, if we back up for a second and look at the shoulders that we're seeing right in here, they're designed for the shoulders no different than anyone else's. Everyone's shoulder is the same. There's like been no innovation there, with the exception of maybe like clone robotics. And our shoulder joint and our hip joints are ball and socket joints. But the way to actuate a ball and socket joint is not really clear. And so what they do is they do a different scheme of stacking three motors together. So everyone's shoulder is the same, but when it comes to the hip design, everyone is doing something different. I mean, it's really hard to say that anyone has the exact same solution. They've all kind of gone back and forth. So if you look at like, Figure, I think P&D Botics, Boston Dynamics, the new Atlas, they sort of decided that the very first joint in their chain is going to be the swinging joint. So it's up there as it's the first one, it's kind of primary. You know, the Optimus bot and the original Figure One bot actually had that down lower as like the third joint in the chain. And the problem with making the third joint of the chain is that its point of rotation tends to be well below. Like you see this actuator sticking out here in the back, it's way up there. It's almost at the elbow. And then this one is way down there. Is that if you kind of create a stack like that, that sometimes that movement, that point of rotation there is very, very low in your chain. And Optimus, it's extremely low. And it's a major problem for Optimus for a couple of reasons. One is it cuts the stride length down. Now, what they've done here is that they've decided we want to make this leg the same as like a human leg. What we'll do is just pull that up higher. So pretty much what you get for the abduction and the twisting motion, which are very important to balance and being able to turn, are up very high. The other advantage to, in a sense, putting things up higher is now the flexion motor there doesn't have to carry the load of that. So it allows it to get slightly higher acceleration. But there's a downside to moving this up higher, and that is it cuts into your torso. And as soon as it starts cutting into your torso, you start losing the space that you need to put your battery pack. So these are the compromises that are constantly going on when you try to build something, is where it's going to be. But it's very important to get that right. Now, from the standpoint of the Optimus robot, is that we've talked about this before, is that the forward leaning motion of your torso, I don't know if you want to call that bend or forward movement or something like that, many other bots actually have a point of rotation somewhere up in their body. So if you want to lean forward, you can lean forward by kind of bending around your belly. You know, you have that. But for most people, actually, it's easier to lean forward through your hip. So that means your hip is doing double duty. It can either swing your leg forward or it can make your body lean forward. So you can use it for redundancy like that. But the thing is, if you bring that point right down here and you decide you're going to use that for the um, redundancy of bending the torso forward, that means the torso bends at that point. You've got a really long length between here and there. And that means trying to get into a car or something like that or a small area becomes more difficult because you're completely inflexible between the two. And so if you're going to use that strategy, you do want to raise it up higher. That's one of the reasons why Figure brought it up higher, is that, you know, they wanted to make sure that that redundancy was used kind of well, to be able to do it. And they didn't want to have their torso eaten up by everything in here. And so they figured out how to kind of package it in down below. So these are all the strategies. And this is what I think is really interesting, is we have to start looking at everyone's hip designs. That seems to be where everyone is focusing. And I think it's gonna be more than just look at what they're doing with a hip. Look at what they're doing with the hip and the torso. It's all kind of integrated in there. And you know, whether someone really figures out like here's the way to kind of solve the whole thing in a nice integrated package, as opposed to I get a lower hip and an upper hip that are very separate, how you try to pull all those things together into something that's neat. So that is where the innovations are going to be, is like right in around here. Because you see, no one's doing anything with the shoulders. It's almost like everyone is happy. I mean, I'm not 100% happy with that shoulder, but, you know, it's okay for now. You know, there's so many other problems we need to solve, that is like a mostly solved problem, and it's an okay solution. It's not super elegant, but hey, it's
But the
okay,
hand
it's clean.
movement,
Yep.
did you notice the hand movement being different a little bit from Figure or the same? Like I feel their hand movement a bit natural, like to human,
Yeah, and
compared to what I see in other
yes,
humanoid.
and again, hand movement is extremely important, and it's really impressive that RL figured it out. That, you know, it went and realized that, oh, when you're walking, you wanna have the opposite movement of the hands. So part of that is helping to stabilize your inertia and everything else, and, also gives you, a l you know, runners know that believe it or not, for a sprinter, one of the most important exercises for a sprinter is, like, doing a lot of work in the upper body, in the arms. Because in order to get out of the blocks, as you're pushing out of the blocks, your body's going forward and you wanna push harder back in the blocks, and so you wanna have, like, a good reaction force there, and a lot of that is why your hand is going down while you're trying to go forward. High jumpers are the same thing. They throw their arms down so their legs push harder to get a better reaction force coming out, so that's why that's a very important part of it, and that's one of the things that, of course, we've learned naturally of that it's there. Now you can sit down and like a physicist can work out, oh, here's what the rules are supposed to be, you know, and see what it is. Or the RL can just go through and like kind of figure it out on its own. And here again, over on the left side, we can see the frame that they brought it out from. That we didn't see it get off at first, but looks like yeah, they brought it down from their offices, and evidently the one thing is that there must be a heck of a lot of engineering going on over there because there's like 3 coffee shops in a row, you know, the Manor, the Luckin, and the Starbucks.
Yeah, I was actually seeing the
Yeah,
coffee shop, but like
it's like
reading
the
them. Okay, three coffee shop next to each other.
is
That's a crazy.
yeah, I mean, for a lot of people, it's like, "That's a red flag, that seems kinda crazy," but at the same time, it's like, "Yeah, man, they have nothing but coffee shops there?" So, but,
It's a Shenzhen, huh? In
I
Shenzhen.
believe it is.
This was your.
Yes, yes, I believe it was, and, yeah, I
Do you have an idea of the price? This is the price for these
I haven't
humanoid
I
robots, really,
had to look
or
at it, but I mean, they were at CES with a smaller version. It looks like they might almost have a version ready for people to buy and bring home. So it's yeah, I don't know much more than that, but, it seems that if you look at their actuators that they're using here and there and everywhere, they're really small. They're really well packaged, no doubt about it. It's they did an incredible job of being able to stuff all that in there and then have the torque capability to be able to walk confidently at this speed. And that's good enough. If everyone's like, yeah, I want to see you do cartwheels. I want to see everyone's like, I don't really that's good enough for most of the work that you need to have. That is adequate speed working in the factory. And I'm sure they can probably get it up to being able to do running and stuff like that, but it's not shuffling its feet along. That is a good, healthy clip and, more than adequate for, just about any situation that you would think of using it in.
so? How do you see all this coming to play? I mean, like, there's all things going on every now and then. We have new company, and it seems they do everything like this. When I never heard about it before, it seems yeah, it's cheaper, but I'm not sure how this will look for the competition speed. Like, what will be differentiator between all these companies to survive and their business model?
It's gonna be the AI. I mean, it's one thing that it's really nice to have it be able to do these things and using things like Isaac Sim or allowing them to build the foundations that they're gonna need. The real question is how smart are these going to be? Does each one of these companies have to solve that problem, or is Nvidia just gonna hand it to them? Because if Nvidia is able to handle it, then these things all become a commodity. It's just like everyone has one. But but if there's some real secret to the AI that only a handful are able to solve, even though they're running it on the Nvidia inference engines, but they've been able to figure out how to solve it. That will be the big difference. And if you think about it, there are so many companies that make drones. And the reason why some of them make drones is that the controller board for it, that basically was mastered a long time ago. I mean, anyone can just buy that thing and a hobbyist can create their own drone without having to figure out the control system or anything like that. It's all in there. So that was kind of it's like, how do you build a thing with these different motors that are on there? They're going to spin the right way to have their balance, and you get IMUs and everything. It's like you just buy it off the shelf. You just go to Amazon and get a controller board, and then you can buy your own motors and you can build your own. And um, and we are seeing a lot of people are building these kind of in their garage because a lot of the controls problems are kind of solved for them just by being able to get a few things offline. Now, some companies will do a better job of packaging this, but we'll have some things that will definitely differentiate them. And some of it might be down to the mechanics. So the AI is extremely as important as it is. As I pointed out before, the business end of the robot are the hands. And it's going to come down to, in the end, who probably has the most dexterous and best hand that's actually able to do something. And if you have a really smart bot, it's able to walk really fast, but doesn't have really good hands, then no one's going to want it. And so there may be some engineering advantages that some people will have, but then again, it'll be like a 2-year advantage. Everyone else will figure it out, and then someone will commoditize it. And
And from your intuition, do you think maybe Figure will be on top of the game, assuming OpenAI, they say that the AGI is coming around the corner? So
it will be, yeah. And it's the big question on all these things is going to be how robust these systems are. They've got to be robust from a couple ways. One is that the AI doesn't have it doing anything crazy, and there was one image. This is how I kind of knew this was real. I don't have that clip right here, but there was another image that someone had that when it was first coming out, and its right leg just suddenly dragged along as if suddenly it went numb in the leg. You know, it just acted really weird. And it's just like, yeah, that's something like I could just imagine an AI doing that. Wasn't quite sure what to do, or was a little bit confused at that point, and the leg just kind of, did something strange. And that's I was more convinced that it was real after I saw that than anything else. Like, yeah, that's like kind of a weird thing. So this comes down to the reliability, that you making sure that the AI always makes the right choice all the time and doesn't hallucinate, as we know LLMs tend to be able to do, and make sure that's robust. And then there's the mechanical robustness and hardness, and that whether this will be able to do it 20 hours a day, 7 days a week, 365 a year. That's going to be the real test. And whether, you buy this thing when it's brand new and you're just so excited, and then a month later it's not working and you're just frustrated. And now you have to buy a new one, right? Then so that's what's going to come down to.
It would be like a
Oh
cars,
yeah,
maybe.
exactly. Everyone,
I feel like the future would be like
yeah,
cars, and you have
yeah,
to
yeah.
buy something for yourself
Yeah,
to put
yeah,
in the
yeah,
home.
or it becomes like a boat that, the best day of boat ownership is the day you buy it and the day you sell it. It's so if it's a piece of junk, then yeah, you may not really be happy with the experience. And so that's gonna be the thing that's, it's robust, and that comes down to the actuator design, and what they're using. So it turns out that you can build actuators that allow you to do things like this very impressively, but it's not clear that those actuators will have a long lifetime. And that's the thing that hasn't solved.
But it seemed Nvidia, and they're already on top of the game so
Yes.
far
Oh, yeah.
in
Oh,
that
and
space and
NVIDIA's got
field.
this.
Yeah.
I mean, I don't see anyone else that's going to come in, swoop in the important part from NVIDIA. I mean, that's going to be tough. I mean, the barriers to entry on that or something else. However, the barriers to entry to building a humanoid bot is not that difficult. And one of the huge advantages that China has, and the reason why they're able to pump these things out, is that they've focused the importance on a lot of different industries. And everyone just thought, oh, drones were really a hot topic a decade ago, and then it became something for hobbyists and stuff like that, and then it became very competitive, and they all just basically came out of China. And a lot of it is because the motors that you need to have for it. You can build the rest of the stuff fairly easy, but you've got to be able to do it, and they scaled that up. And so they are building these drone motors like crazy. They have the ability to do it, so they can produce as many of them as possible. And then it turns out that, well, it's not that much of a difference between what's going in the humanoid bots. Some changes, but for the most part, they already have the production line set up that they could just tweak them and start producing. And that's why there's so many of these Chinese robot companies are showing up, is because the availability of the actuators and almost be able to size them the way they want is very easy, because they have so many companies there. They're just doing it. And this is something that's the West doesn't have the capability right now to be able to pump out the actuators that you would need to have a fleet of a million bots, which we know has been talked about and many times, and is like come up again, because Elon mentioned that, I think in an interview a day or two ago, of what their production rate is, which is about what everyone was guessing it was going to be. But when someone finally comes out and sort of verifies and validates that is where they see they are, then suddenly everyone starts to notice. And now it's like, oh, okay. So a million bots, how many actuators are in the bot? It's like in the order of 50. Oh, so you need to be able to produce 50 million actuators a year. So you got to think of it in those terms of like all the components that are going to need. You're going to need lots of those things. And the thing is there's different actuators at different sizes. And like their hand right now is like 24 actuators per hand. And that's not including the wrist. If we put that in there, it's gonna be about 27 just for that lower forearm that you need to have, and you get 2 arms. And so that's a lot per bot. And so you need to be able to start scaling your production lines to be able to do something like that. And, how long that's gonna take, in countries outside of China is a big question, because, right now in China, they have that capability, for sure. And now there's another walking video we might want to take a look at. I think we discussed it a little bit, but we didn't really go into it the last time. And that was this one. Yeah. And so this is Optimus going out for a walk. And there were some interesting aspects to it.
It's completely different. The difference between the two is
Yes.
significant. Like this is use reinforcement learning, you
Also,
said. So,
yes. At first time.
so why they managed to get this perfectly, and well, just like they can do
Yeah.
that?
Well, this is they were using pretty much, standard control system before for the lower body, and it looks like they finally got over to reinforcement learning. And which and my reaction was like, man, it's about time. I thought they would have been there a lot sooner. So the thing about this that was pointed out is that it is walking without vision. So it has no idea what's there. So it's more or less, feeling the terrain with its feet to sort of figure out what's going on and having to recover. And and that's a very good way to learn to walk. No doubt about it. You don't have to worry about the sensor fusion issues. You don't have to worry about the conflicts between what your eyes is telling you is going on and what you're actually feeling with your feet. And then here is very important, that slip there. I've been concerned that Optimus doesn't have the speed and the movement of its legs, as potentially the reason why I wasn't walking very fast. And that kind of demonstrated that they do have maybe explosive acceleration when they need it, because in order to recover, we could see that that leg had to go back really quickly to be able to do it. So it may be other reasons that they're limiting themselves as far as the speed at this point, but it may not be that the joints can't actually go. And that's a linear actuator that they have down there. So if we kind of get back to that point, and even up there,
So another bot to
yeah,
use rotary.
yes,
The other one,
that's all
the
rotary.
train,
So they're all
the one
rotary.
that before
Yes,
that we
and you can't see it here in
rotary.
Optimus, but built into Optimus are actually two linear actuators, one to control the knee and one for that swinging motion that's back here. And as part of the reason they're using that linear actuator to do it, to sort of force them to make it the third joint on down, and the other joints are up a little bit higher. And it'll be very hard for them to bring that point of rotation for the flexion up much higher using that particular strategy. But I was wondering, it's like, I wonder if they can ramp up the acceleration of that linear drive fast enough, and we can see that, whoa, it's able to get it back pretty quick. So that knee had to get back there pretty quick to be able to do it. And then, it's throwing its weight around a little bit, with its arm and everything to try to get the balance. And with enough reinforcement learning, this thing will be able, not as, I'm assuming Optimus will be able to, basically all the bots will be able to do backflips off the balance beam, just like a gymnast. And when you have that degree of control and ability, that can tell you a lot about, then the balance of these things will be incredible.
And how many iteration to come up with? Well, I'm just curious because I wish I can work in one of these platform with reinforcement learning, but how many iteration they came up
Ooh, that's a
until you
good,
reach a
that could
solution
be
like that?
millions.
Like
It,
if
it,
there is
it,
many
it could be a lot,
solution,
but this strategy has been used by a lot of different researchers. ETH may have been one of the first, if not the first, where they took their quadruped bot, the animal, and they just had it in their own simulator, and it was just flailing around and learn to do it. And there's been a lot of other examples of um, simulated bots doing something like that. But then they took it to the real world. Then I think there was like one example of some of them where they actually took like a real physical bot and just like had it go through it, and eventually until it could sort of figure out what was going on. Now, I think this is probably something almost anyone could do. I mean, you need a certain amount of compute, but I don't think you need like the crazy compute that you need for a large language model. So it is something that you would be able to go through and do the iterations enough to be able to learn to do the walking. And that's part of what Isaac Sim is all about, is to give you the ability to learn to walk and walk on different kinds of terrain. And that's what was really interesting to finally see with Optimus. Is like, okay, finally it's not walking on flat terrain. It's uneven terrain. It's not. It's very slippery. It's unpredictable, and yeah. So that means that they've turned a corner on the walking, and maybe in the next months or two, we'll see something a little bit different coming out, and maybe finally that nice walk, quick walking gait that we've been sort of waiting to see is like, okay, can because it has to double the speed from what we've seen. It's really half of what is useful speed. And once it gets up to there, it's all right. And again, I'm not expecting it to run marathons or to set the world record in the sprint. That's not important. It just needs to be able to walk at what is considered the proper pace for being able to do work.
think we will end it here. What you should, I think you still have to travel a couple of
Oh,
hours.
but that's still in a few hours.
Um,
See,
maybe
yesterday I was almost ready to go, and I was thinking, oh, do I want to leave early or something like that? And then I checked on the found out they pushed it off. They pushed it off, another 24 hours. So it's like, oh. And I've learned before there's been so many times I've jumped in the car to go to a SpaceX launch, and I get halfway there, and I check to see that it's been, either scrubbed or, delayed a lot of hours. So, it's a 1 a.m. local launch, and takes 3 hours to get there. So if I yeah, I get many hours. So I'll be driving the dark. Right now is like a bad time to leave because I think the traffic is pretty. I've got to pass through Orlando, and you know what's in Orlando? Disney World. Okay, the traffic around there is just horrible, especially during certain times of the day when people are trying to get there and get out. And so usually,
But you're in Timber. You
yeah,
live in
yeah,
Timber, right?
Sarasota. Yeah, more
You're in
accurately,
Timber.
Sarasota.
Okay.
So it's about a 3 hour drive to go ahead and do it, and I kind of know how to avoid it. I go through Celebration, take a southern route to kind of grab, but still, as you approach, the traffic is in that. And of course, they always have to throw in a construction project on top of it. It's like, yeah, we got to widen the road for this bad traffic. So let's cut down a lane, for 3 years while we widened it. And, all that does is mean more of those Disney people are now going to be further away from Disney, which means the commute's going to be even longer and worse. It never works. It's like this whole idea. It's like, all we need is another lane. It will solve our traffic problems. Like, no, what it actually does, and every study has proven it, it's made it worse because it encourages people to go further away from where the actual problem is. Yeah.
Okay. I hope that you manage to arrive out
Yeah.
any traffic jam or anything.
Yeah.
What we should talk next episode? Like, do you have something in mind?
I mean, I'm sure things are going to pop up because there's just so many other companies that are out there, whether we get down to the walking out, but I'm sure we'll find something. I don't know if we've sort of talked about the hand to death. And I think there will be some other things. Probably out of CES, and I wouldn't be surprised is that most people are probably keeping their announcements, till after CES because otherwise you get drowned out. And I think the big thing is that more people are beginning to realize that, the importance of the humanoid bots. It's starting to kind of go out of this smaller area that Wall Street and basically the public at large, um, the mainstream media is starting to talk a little bit more about it, which means it's there, and so that debate's going to be rather interesting. And who knows? One of our discussions, might kind of come down to the societal impacts of it and the concerns that people have at very angles. And one of those, of course, is that it's going to take my job away, and it's not clear that it is, and I really don't think it will. And the short end of it, and we can get into like a lot of detail at some point, is like, what are the jobs that it's taking away when there's like all these job openings everywhere? That a lot of these companies are actually wanting to do it because they cannot staff positions, and when they do staff positions, the turnover is just so high. So it's in my view, these they're not so much taking away jobs as they're taking away toil. Because when you have a company that has perpetual job offerings for the same job, even though you'll go in there and say, "Oh, everyone's here. I see you're fully staffed." I go, "Meh, just wait till next week." You know, 10% of them are going to be gone. They haven't told us yet, but we know 10% are going to leave because they don't like the job. And and so that just kind of goes on, and they're constantly trying to fill those jobs, and they can't, and they're tired of it. And so that's really what they're trying to do. And that if you ask anyone who is saying they're taking away the job. It's like, okay, what's the job they're taking away? And they'll be talking about, oh, they're going to take away the job. So, have you ever applied for that job? Would you ever apply for that? Would you recommend a family? Oh, no, I wouldn't want to do it. So, exactly. If that job is beneath you, that job is beneath them as well. And so, if you're happy with the fact that someone is doing that toil for you, for your benefit, then maybe you should take that job up sometime. And then, after you've taken that job, decide, is that something that we should be using humans to automate this process, or should we be using machines to
Hmm.
automate this process? And that's
Will
it.
I admit with
Yeah,
you?
yeah.
I think it's true. It's
It's
true,
it's
and
gonna take
I
it. It's
feel it because
it's gonna take
some of
away
the job I
toil.
think it takes. Yeah,
Yes, yes. It's not
yeah.
taking away
I think
jobs.
it's very important topic. Yeah,
Yes, yes, yes,
I totally agree with you. I feel that, and I think not too. I think yeah, I think it's very complicated topic, and I think it has many dimensions, especially for
yeah,
how our
yes.
society run. I
Mhm.
think low wage income. I think there's many things that I think we should talk about.
Yes, and how
But
you do it, and that in many ways it could be empowering for a lot of people that you now start to see this as a work assistant. People going in there to make their jobs more comfortable because a lot of these jobs are not a career. I can tell you that you go in there and you look at it and you say, Can you imagine that that person's gonna do that job for 40 years and retire off of that? No. It's like even like roofing, people get paid pretty well in roofing. It's really not a career, okay? Because you look up at the roofing and they're all young people up there, okay? You're not seeing people that are in their 50s or 60s doing a roofing job because it is physically demanding and it's not something you can do. So a lot of times these jobs are out there, they're jobs of convenience that people kind of need between something or, the certain set of desperation. But, once they get their finances or even if, their finances aren't in order, many times they're quitting because it's like, it just is too hard. This is not something they want to sustain.
Someone asked this question, I think I read it. They asked if the robots can do the work for us and we have the universal fixed income for every human being, would you still do job? Like, I think there's two dimensions for job. I think physical labor and the brain labor. So I think someone doing the roofing, this is physical labor. So I think I'm not sure if this is something could be helpful, but what about the brain labor? Some people who do the brain labor, and assuming we have AGI sometime soon, how
I'm
this will
I'm I'm more I'm
impact
more concerned
everything.
about that taking away because that's where we get a lot of our satisfaction is in problem solving and using our brains, where many times we're using our brains to do a physical problem and kind of solve it. So there are a lot of things that people do that used to be work that we now call hobbies because people enjoy doing that. And that's not something we want to take away. I mean, it's like ironically, I do like doing the dishes. It's like when we have a big meal of Thanksgiving or something like that, or from visiting us, I volunteer to do dishes and say, "Oh, it's like, no, I actually enjoy it." And a lot of people kind of find now it becomes drudgery when you have to do it every single day. But there are actually times where I don't mind doing that. I don't mind doing some of the work around the house. But at some point, when it goes from being something you enjoy doing to it's toil, it's drudgery that you constantly have, it's kind of nice to do it. And so I think we will see that people will still get, that guilty pleasure out of sometimes doing some task over here that you think, oh, that's supposed to be for the robot. It's like, no, that's okay. I don't, and so it doesn't mean it takes it away. And I think it was funny. It's like, I think there's a certain amount of, it's like over 30 years ago, I think Buick had an ad of showing like someone with a household robot going around, like doing all the tasks. And when it came to the car and like the robot was going to drive the car
What's the name
and
of that?
it was like Buick.
What is the name of that?
It was a Buick ad, from GM, from General, and then this is, like, back in the '90s, and the owner just, like, pushes the robot out of the way and says, "No, I'll take this." The idea of that we get pleasure in driving as opposed to having to be done, and it's sort of funny right now because we're going to the full self-driving thing. It's like, yeah, there are times that I really want the car to drive, but every now and then, yeah, you do get some pleasure from driving, and this is the thing that you're finding is that a lot of people saying that, yeah, sometimes driving's a drudgery and I don't want to do it. But there are other times that, yeah, I want to go for a Sunday drive. It's like you want to get in there, you're out there, just kind of
I
drive
think that's
around a
come
little bit.
down to society. I think
Mhm.
that's come down to society who set the technology, like the
Yeah.
trend for humanoid. I think there's, to be honest with you, I feel like sometimes we follow blindly a trend and we don't question it,
Yeah.
the
Yeah.
complication and
Mhm.
consequences about the technology sometimes. But so
Yeah.
I think it's very crucial topic for everyone
Right.
to be knowledgeable
Right.
about.
Right.
So
Right.
we can talk
And
about that for
it
sure.
and the most important thing is that when you kind of get to that universal basic income, um, part of that is there has to be an enabling part of it to allow people to start um, fulfill. It doesn't mean that you just get to sit around all day and watch Netflix. I mean that there's got to be a little bit more that you actually are learning something, developing a skill, and enriching yourself. Enjoying life the way you're supposed to. It's just that it's not coming with like a lot of that drudgery, and that can be hard for a lot of people. Some people are very motivated, self-motivated, and others that may be very, very hard. And I don't think all jobs are necessary because uh, there's a good chance that s- you will be working next to a bot. The bot's not going to take all the jobs. It might be that there are people like, yeah, I like this. Can I go down and do it? And say, yeah, sure, come on in. And it could be that there are going to be some of those jobs that they really want people to do it, and people enjoy doing it. I know a lot of people that love being servers in restaurants. They just have so much fun. They love the interaction with the customers and stuff like that. It's something they actually enjoy. Some people, it's drudgery. It's like what they got to do for it. Other people, it's just like it's a natural. They like doing it. If you say you can't do it anymore, they'd be very disappointed. At the same time, there's a lot of customers that actually like a good server. It's like it's something else, and it's like yeah, we had the robot a few times, but every now and then. So it's going
I
to be
think it's
there.
a human
Yeah,
connection. You can't take it away. The human
there will be a
connection
human
is just
connection.
something
Yeah, yeah.
irreplaceable.
The bot will be kind of entertaining for a while, but at some point, yeah, there's going to be these people who's like, they'll set up a restaurant and they'll say humans only, something like that. It's like, I don't know if you remember that line from Demolition Man. It was like absolutely hilarious. That Rob Schneider line. That he's picking up the phone, and he's actually picking it up and says, "If you'd like to talk to a human, press one. Otherwise, it's going to be automated." Because at that point, people preferred to talk to the automation than the human. Whereas we know the joke was in 1990, everyone hated that, right? They
Yeah,
absolutely hated that idea.
that's
Yeah.
true.
Yep.
Yeah.
Yeah.
Okay, that's
Oh,
great. Okay, I wish you a
okay.
great day and
Yeah.
see you next time.
Yep. You're welcome. Okay. Yep. Okay. Yep.